What if I told you that the planet closest to the Sun, the one scientists assumed was a dead, boring rock, turned out to be one of the most bizarre and confusing worlds in our entire solar system? Not because of what we expected to find, but because of what we absolutely did not expect. Ice, magnetic tornadoes, craters that science has never seen anywhere else. A core so enormous it defies everything we thought we knew about how planets are born. For decades, Mercury was the forgotten planet. Too close to the Sun to observe safely, too small to seem worth the effort. But when humanity finally sent cameras close enough to capture its surface in real detail, everything changed. Today, we're going back to those first real images of Mercury. And what they revealed is genuinely stranger than fiction. The planet nobody wanted to visit before we talk about what the cameras showed. Let's understand why it took so long to get them there in the first place. Mercury sits just 36 million miles from the Sun on average, roughly 2.5 times closer than Earth. That sounds like it should make it easy to reach. It doesn't. In fact, Mercury is harder to get to than Neptune, the farthest planet in our solar system. The Sun's gravity acts like a massive slingshot that pulls any approaching spacecraft off course, and the temperatures near Mercury swing between 800 degrees Fahrenheit in the daytime and negative 290 degrees at night. Any spacecraft sent there has to approach with extreme caution, carefully bleeding off speed across years of flight while surviving conditions that would destroy most hardware. The result? In all of human history, only 2 spacecraft have ever visited Mercury up close. The first was Mariner 10, launched in 1973. It made history, immediately becoming the first spacecraft ever to use another planet's gravity as a slingshot. It borrowed speed from Venus on its way in, and when it finally swung past Mercury, the images it returned shocked scientists. The surface wasn't the featureless wasteland they'd imagined. It was covered wall to wall in craters, a battered, ancient world that had taken a brutal cosmic beating. Mariner 10 also detected something nobody expected: a magnetic field. For a planet this small, that was genuinely puzzling. And it caught a hint of something thin and ghostly clinging to the surface, a barely there atmosphere that had no right to exist. Over 3 separate flybys, Mariner 10 mapped nearly half of Mercury's surface and took over 2,700 images. Then, in 1975, it went silent, still orbiting the Sun somewhere out there to this day. But half a map wasn't enough. The questions Mariner raised needed answers. If you're finding this as mind-blowing as I am, hit that like button right now and subscribe if you haven't already. We cover the universe's greatest mysteries every week. And trust me, you do not want to miss what's coming next in this Vid Messenger Arrives A&D. Everything changes 30 years past. Then, in 2004, NASA launched Messenger, the first spacecraft ever designed to actually orbit Mercury rather than just fly past it. Getting there took nearly 7 years. Messenger looped around the inner solar system multiple times, using gravity assists from Earth, Venus, and Mercury itself to slow down enough to enter orbit. By the time it arrived in 2011, it had already traveled 9 billion miles. What it found during 4 years of orbital observation rewrote our understanding of this tiny world completely. The first thing that jumped out from Messenger's images was the sheer violence written into Mercury's surface. The planet is covered in craters, over 560 named ones, and countless more unnamed. But these aren't ordinary craters. Mercury hosts more craters with central peaks than any other body in the solar system. Over 110 craters on Mercury have a mountain rising from their centers, compared to just 17 on the Moon. The physics of Mercury's higher impact velocities caused by its proximity to the Sun, almost no atmosphere to slow incoming rocks, makes it a uniquely brutal place. The largest crater, Caloris Basin, stretches 963 miles across. To put that in perspective, it's roughly the size of the continental United States east of the Mississippi River. Scientists believe the impact that formed Caloris was so powerful that the shockwaves traveled through the entire planet and warped the terrain on the exact opposite side, creating a chaotic jumble of ridges and furrows scientists call chaotic terrain. But here's where it gets truly strange. Messenger found crater types on Mercury that don't appear anywhere else in the solar system. Elliptical craters, formed when an impactor strikes at an extremely shallow angle covering about 2 to 4% of the surface. Polygonal craters with sharp angular edges, caused by the fractured structure of Mercury's ancient crust. And then, there are ghost craters, ancient impact basins almost completely buried under layers of hardened lava, only visible today as faint circular ridges barely poking above the plains. These ghosts hint at an active volcanic past far more dramatic than anyone imagined. The volcanic history hidden in those images turned out to be one of Messenger's biggest discoveries. Mercury's surface composition, heavy in sulfur, calcium, and magnesium, combined with photos of long-dead volcanic vents, suggested that billions of years ago, this tiny world was covered by a global ocean of molten rock. Volcanoes erupted across its entire surface. Over time, as it cooled, the planet shrank, cracking and wrinkling like a drying raisin, forming the long cliff-like ridges called scarps that Messenger photographed winding for hundreds of miles across the surface. And then the cameras found something that still puzzles researchers today: hollows. Shallow, irregular depressions scattered across Mercury's surface with no edges and flat bottoms, found mostly inside impact craters. They look like nothing on Earth, nothing on the Moon, nothing anywhere else we've explored. Scientists believe they're still forming right now volatile compounds slowly vaporizing out of the crust and leaving pits behind. Which means Mercury's surface is still actively changing. Scientists estimate that 99% of Mercury's visible surface could look completely different 25 million years from now. Messenger also confirmed what Mariner hinted at: water ice at Mercury's poles. Despite sitting this close to the sun, the poles never receive direct sunlight. Permanent shadow keeps them cold enough to preserve ancient ice, possibly delivered by comets billions of years ago. There's even evidence that some of that ice might be buried beneath layers of dark organic material. And then there's the magnetic field anomaly that Messenger revealed. Not only does Mercury have a magnetic field, it's offset. The center of the magnetic field sits about 20% of the planet's radius north of Mercury's geographic equator. That's a shift with no parallel in our solar system. The result is that the southern hemisphere is far more exposed to solar radiation than the north, constantly getting hammered by particles from the sun. The final image Messenger captured before fuel ran out in April 2015 was a photo from Mercury's orbit of almost the entire solar system, a cosmic family portrait taken from the inner edge of our neighborhood. Then the spacecraft was deliberately crashed into Mercury's surface, creating one final new crater, and the mission ended after a decade of revelations. The mystery continues, but the story of Mercury isn't over. In 2018, the European Space Agency and JAXA launched Bepi-Colombo 2 spacecraft flying together toward Mercury right now, designed to answer the questions Messenger couldn't. Why is Mercury's magnetic field off-center? Where did all the ice come from? What are the hollows made of? And what does their formation tell us about the planet's future? Bepi-Colombo is expected to enter Mercury's orbit and begin full operations very soon. And when it does, the images it sends back could once again rewrite the textbooks. Mercury is proof that the most overlooked worlds often hold the deepest secrets. A planet we thought was dead turned out to be a geological archive stretching back 4 billion years, scarred, shrinking, icy, magnetic, and still evolving. The first real images of Mercury didn't give us a boring rock. They gave us a mystery. And we're still solving it. If you want to be here when the next chapter drops, subscribe. The universe is stranger than you think, and we're just getting started.